let's solve question number 16 from the year 2024. This is a January 2024 question paper. This question is related to momentum. And so let's solve question number 16. In the question number 16, they have said a skittle is a wooden object that can stand upright on one end. So this is a skittle, which we have seen a game playing on a skittle when a ball is thrown towards a skittle. In a game of skittles, a ball is thrown at some skittles to knock them over. Okay, the game which we have more or less everyone have watched in National Geography actually. The diagram below shows the ball just before it collides with a skittle. So the skittle was standing tall when the ball was approaching it. So it was stationary. The skittle was stationary and the ball had an initial velocity. Okay. So moving forward to the question, they have said the graph below shows the velocity of the skittle varies with time. Okay, so when the skittle was collided with the ball, the skittle also started to move in this direction. So the velocity of the skittle varied. The velocity of the skittle varied with time. The time shows on the graph just start before the ball hits the skittle. Okay, so this is a velocity time graph of the skittle given. We all know the gradient of the velocity time graph gives us the acceleration. So let's move to the question and see what they have asked us. In the question, they have asked us to determine the average acceleration of the skittle during the during the collision. So we have to find out the average acceleration. We all know that the gradient of the velocity time graph gives us the acceleration. The gradient of the velocity time graph gives us the acceleration. So let's go and find it out. So in order to find out the the gradient, we have to take these 2 points, right? This is the point from which the skittle started to run, or when the ball just collided with the skittle. This is the time when the ball just collided with the skittle. This is the time, and this is the time when the skittle stopped moving after the collision, because of the force of the ball, the skittle started to move in this direction. So we have to find out the acceleration of that time. So in order to find out the acceleration, we have to find out the gradient. We all know the gradient of velocity time graph gives us the acceleration. So here acceleration will be gradient of VT graph. So we have to find out the gradient. So in order to find out the gradient, we can write it in such a way that gradient is equals to y2 minus y1 divided by x2 minus x1. This is our gradient formula, right? We all know this gradient formula from class 6. So we have to find out the y coordinates and the x coordinate. So if we look at this coordinate, we can say this coordinate is this is the coordinate, which will be, if this is 2.5, this is 2.9, and it is between 2.9 and 2.8, so it will be 2.85. And if we take this coordinate, we can say it as it is 48, because if it is 40, it is 42, it is 44, it is 46, it is 48. And if we take these two coordinates, it will be 15, and another one will be 0. So this is the x and y coordinate, and this is the 2.85 and 48. These are the two coordinates, x and y. This is the two coordinate, x and y. So we can put them, we can write it down as, we can take this as x, so we can write it down as 2.85 divided by 48 into 10 to the power minus 3. We are taking 10 to the power minus 3 because it is given in milliseconds, minus this 15, which is going to be 15 into 10 to the power minus 3, which will be equal to 86.3 ms minus 1 to ms minus 2. So this is going to be our acceleration. We have to just go and put it down there. Our acceleration will be 86.3 ms minus 2. Okay, so we are done with question number A. So let's move forward to the question number B. In the question number B, they have said, explain how Newton's second and third law of motion apply to the ball and the skittle during the collision. How do Newton's second law and third law? Okay, so the thing is, it was the skittle and the ball was approaching towards it, right? The ball was approaching towards the skittle. So we know, according to Newton's third law, when the ball and the skittle was together, when the ball collided with the skittle, the ball exerted a force on the skittle, and the skittle also exerted an equal and opposite force on the ball. So writing these things, we are getting 3 marks. Okay, so the ball is exerting a force on the skittle, and the skittle is also exerting a force on the ball. So there is a resultant force on the skittle because it was stationary. There is a resultant force on the skittle on the left. There is a resultant force on the skittle on the left. And as the ball already had force on the left before colliding with the skittle, and after colliding with the skittle, just because of this force of the skittle to the ball, there is also another force right here in the right direction. So it already had an acceleration. So if there is a force in the opposite direction now, its acceleration will decrease and it will decelerate, because the resultant force right now, maybe it can be in this direction or in direction, but the net force is not only this. There is also another force acting on the opposite side. So this is an opposing force. As this is opposing force which has been exerted by this settle of the Newton's third law pair forces, this settle is also exerting the equal and opposite force which the ball has exerted on the settle. So this force is an opposing force which is acting on the ball, and that is why the ball will decelerate. So and the settle will accelerate on the left, because the settle was stationary and it had only one force, but the ball had a force on the left side at the first, but after colliding with the settle also exerts an equal and opposite force according to Newton's third law, and just because of this opposite force, now the ball will decelerate because it has two forces on opposite directions. So we can go and write it down to get a perfect 6 marks on this question. So let's go and write it down. Okay, the first point that I will write will be the ball exerts a force on the settle. It's obvious that the ball will exert a force on the settle. The settle applied a force to the ball. The skittle also exerts a force on the ball according to Newton's third law. This is our point number 2. And our point number 3 will be the two forces are equal and opposite in direction. So we are done with 3 points and we have already got 3 marks, and the question is about 6 marks. So we have to write another 3 points. The another 3 points will be, these 3 points are a bit difficult to write. We all know, as the settle and the ball collided, there was a force on the settle on the left. So we can write there is a resultant force on the skittle to the left. There is a resultant force on the skittle to the left. And the fifth point will be the skittle accelerates there is a resultant force. We know force is equals to ma, so the ball will accelerate. The ball accelerates according to Newton's second law. The ball will accelerate just because of this formula, F is equals to ma. And the last point will be the ball decelerates and the skittle will accelerate to the left. So we are done with 6 points for 6 marks. Let's move forward to the next question. In the next question they have said a ball is thrown again. So this is our skittle and the ball was thrown again and collided with another stationary skittle. So its initial velocity was 0, but there will be a final velocity because it will move just because of the collision with the ball. Its initial velocity is 0, but there is an initial velocity of each. Its initial velocity is 7.2. They have given during the collision the horizontal velocity of the ball from 7.2 to 1.6. So this 7.2 is its initial velocity and it decreases to 1.6 after the collision. So the horizontal velocity of the skittle immediately after the collision is 3.1. So its final velocity is 3.1. The final velocity of the horizontal velocity of the skittle is 3.1. So this is our final velocity and we don't know the initial velocity. No, yes, you know the initial velocity. Initial velocity is 0 because the skittle was stationary. We know the initial velocity of the ball 7.2 and the final velocity as 1.6. This is the final velocity of the ball. So they have asked us to determine the mass of the ball and they have given us the mass of the skittle. So we can use the formula of momentum. Momentum is equals to mass into velocity. We can say mass of the skittle into the velocity of the skittle plus the mass of the ball into the velocity of the ball is equals to mass of the skittle into velocity of the skittle plus mass of the ball plus velocity of the ball. This is final or after and this is before collision. We know before collision is equals to after collision. So let's go and write it down. The answer will be, we know the mass of the skittle, but the initial velocity of the skittle was 0. So the mass of the skittle is 1.4 into 0, which becomes 0, plus the mass of the ball is, mass of the ball we don't know. We have been asked to find out the mass of the ball. We will write it and the velocity of the ball was, the initial velocity of the ball was 7.2 is equals to mass into 1.6 plus 1.4 into 3.1. This is the mass of the skittle and the velocity of the skittle is 1.4. The mass of the skittle is given. This is for the skittle and this is for the ball. This is for the ball and this is for the skittle. So we can find out this mass and this mass. As we don't know this mass, we can take them into common and the answer will be 1.4 into 3.1 divided by 7.2 into minus 1.6. The answer will be 0.775 kg. So this is the mass of the ball. So we're done with question number 16.